All right, so this is a video on section 2.1, which is on sets and Venn diagrams. I think you'll find, there's a lot of technical details, especially in terms of the sets. There's a lot of terminology and then symbols we're going to learn. Some of those symbols and terminology you may not end up, needing to teach in elementary school, but certainly in grades 6 through 12, students are going to see these in math classes. So, it's definitely good to know where students are going to be headed. And then in terms of the Venn diagrams, you'll definitely be working with students on Venn diagrams, as early as even, first grade. And you'll be setting the stage in even pre-K and kindergarten by talking about what different groups of things have in common. So let's just jump right in. So let's talk about what a set is. So there's lots of words to express groups of things, and that's basically what a set is. It's a collection of a collection or group of objects. So for instance, flock of birds or herd of cattle, bunch of bananas, school of fish. So a set is just, a group of, it could be anything. It could be a set of letters, or it could be a set of numbers. It could be a list of all of the names of the people in your class. There's no restrictions in terms of what can be in a set. So let's do a couple of examples. So when we are listing out sets, we always use curly brackets. And so for the first example, the set of vowels, we would write a curly bracket and we would write the list of vowels. So A, E, I, O, and U. Now with sets, the order doesn't matter. You'll find that a lot of times, especially in the book and the homework, when I do examples, I do like to put things in order if it's numerical, just because I think it gives some more order to the problem, but it's not necessary. It doesn't make the set wrong if for some reason you put it in a different order. And you don't need to list an element twice. And we'll get to an example that explains that in more detail. So let's look at the next one. So the set of all even numbers between 10 and 20. So what does the word between mean? Do we include 10 and 20 or no? So if we're wanting the even numbers between 10 and 20, you are not going to include. So don't include 10 and 20. So you're going to start with the first even number after 10. So that'd be 12. 14, 16, 18, and you're going to stop at 18 because the next one would be 20. We're not going to include those. The next one, the set of letters in the word Mississippi. So here comes that rule where we don't need to list an element twice. So let's think about all the letters in Mississippi. So there's an M in Mississippi. There's an I more than once, but I only need to list it one time. There are multiple S's, and there are also a couple P's. So the set of letters in the word Mississippi is the set of M, I, S, and P. And I could have written those in any order, but I don't need to list the letters more than once if they repeat in the word. Okay, so next one, the set of whole numbers. If you're not sure what the set of whole numbers is, one way to kind of remember, this is a trick I learned a long time ago and it helps me. I think of the O in whole and I think of the zero, the number 0. Whole numbers are counting numbers, and we include the 0. So I start at 0 and then I work up from there. So all the positive counting numbers. And I put a dot, 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 which is called an ellipsis, and that just means it goes on forever. It's an infinite set. The set of natural numbers, on the other hand, does not include 0. So really similar to whole numbers, just no 0. So we start at 1, 2, 3, 4, 5, and that set also keeps going forever. The set of integers, okay, is the set of positive and negative whole numbers. So that also includes 0. So I'm going to put an ellipsis on the left side here. This is also an infinite set, so I can't write down all the numbers, but I can start. I'm going to write a couple negative numbers, and including 0, and then some positive numbers, and I'll put a dot, dot, dot on either side, and that way we get the idea, negative and positive whole numbers, and making sure that we include 0 since that's a whole number. And then last but not least, the set of even numbers between 10 and 20, so similar to the one above, that are divisible by 5, meaning 5 goes into the set. So let's think about what the set of even numbers between 10 and 20 is. It's this set right up here. Which one of those numbers, if any or all, is divisible by 5? So does 5 go into any of those numbers? So the answer is no. So the answer, so the set of even numbers between 10 and 20 that are divisible by 5 is the set with nothing in it. So you can write that like this with curly brackets and nothing in it, or you can use this symbol. It's like a circle with a line through it, and both of these stand for what we call the empty set. And it's good to have this terminology, because if you're answering a question like we just did and you actually, you find that there aren't any elements in that set that answers that question, then you need a way to be able to write that. So either one of those are acceptable ways to write the empty set. So it can get a little bit cumbersome when we're being asked questions and trying to write answers in terms of like describing sets and what's in the set and what's not. So we have some notation to make that a little bit easier. So one of the symbols that we have is this symbol. It looks like a curvy E, and this just means is an element of, and then that symbol with a line cross through it is not an element of. Okay, so this first example here, okay, we use anytime we use uppercase letters, that refers to the set itself. So we're going to call set A, the set of letters in the alphabet. So A, B, C, D, E, all of the letters in the alphabet. An example, if we're trying to come up with an example using the word element, it could be C is an element of A. And the way we would write that is C, like the lowercase c, is an element of set A. So it basically means C is inside of the set of all the letters in the alphabet. Okay, if we wanted to write 4 is not an element of A, which it's not, since the number 4 is not part of the alphabet, then we would say 4 is not an element of A. So that's how we would use that terminology. So for the next part, this would be a great place to pause the video and try these on your own. There are no one right answer for all of these. You can make up any sets you want as long as it fits the description. So for example, if set A has letters or words, make up a set that has letters or words in it. And then describe an element that might be inside that set, and then an element that's not. Okay, so I'm going to make up some sets here. And they could be completely different than yours, and that's okay. So I'm going to call it uppercase A. If it has letters or words, I'm just going to write letters since I don't have a ton of space. Let's say it has letters B, C, F, and G. And again, I'm making this up. Describe an element in the set. So letter G is inside of set A. Letter W is not inside of set A. Okay. Set B has numbers. So maybe this set consists of numbers 50, 100, 150. Describe an element in the set. 100 is in set B. 200 is not in set B. Okay, and then C is empty. We could say C is the empty set like this, or we could use the empty set symbol like that. Describe an element in the set. So if the set is empty, there aren't any elements inside, so I'm just going to say not applicable. Can't answer that question. And then describe an element not in the set. You can make up anything, any number, any letter, any word, any color, basically anything. So we could say, I don't know, letter Z is not in the empty set. Okay, so that's all the notation in terms of sets. There's a little bit more notation up ahead having to do with subsets, but that's sort of the basic notation. So where do kids use sets in their everyday life? So when is this going to pop up in elementary school teaching? So below, this is just a snapshot cut right from the NCTM, which stands for the National Council of Teachers for Mathematics. So sorting, classifying, and ordering facilitate work with patterns, geometric shapes, and data. So we could give kids things like a package of stickers, or maybe a bucket of blocks, or maybe a container of markers or crayons, and then they can sort them and you know, as early as pre-K, like what's in common, what's not in common, you know, and they can look for things like color, size, design, you know, shape, smallest, largest, biggest, you know, there's a lot of different attributes that they can look for. And one diagram that's helpful in describing groups of things and identifying what's in common and what's not is a Venn diagram. So I'm sure many of you have seen a Venn diagram before. Hopefully, you know, you've used one at some point in your life. I know with my kids, they started using Venn diagrams as early as probably first grade. A lot of my kids have used hula hoops on the floor. That's a great way to do a Venn diagram in the classroom, and you can just, you know, set them on the floor, have them overlap, and then you can, you know, sort the blocks or the markers or the crayons or stickers, whatever you have to sort. And we're basically just comparing, you know, two groups of things. Now you can have Venn diagrams with more than two groups. Like in this diagram here, we just have two groups. So we have the multiples of 5 here on the right and the even numbers on the left. You can have Venn diagrams with 3 and 4 and even more. We're going to focus on Venn diagrams with 2 right now. But let's go through and actually identify what all of the parts are. So I think the most important thing in terms of Venn diagrams is for you to be able to look at the diagram, and if you're asked, you know, or I'm sorry, let me back up. You look at the diagram and just being able to identify what all the different sections mean. So let's start with the universal set. So the universal set is just the description or the list of everything that's in the diagram. So all elements in the diagram. It's helpful to know what the universal set is so that you know what's being considered when we're making our groups. So for example, if you're in the classroom, your universal set might be the entire bag of stickers or the entire box of crayons. Or maybe it's just the box of crayons that are primary colors, so you know what's being considered. In this case, the universal set is all whole numbers that are less than 100, so anywhere from 0 to 100. So numbers 0 through 100 is the universal set, and we call the universal set uppercase U. Okay, so let's look at each part. So this section right here in the middle of the Venn diagram, try to write, and this would be a great place to write to stop the video and examine. So what is this middle section? What does that represent? What does this part of the circle represent? What does this part of the circle represent? And then what is the outside of the diagram? What does that represent? And see if you can write a sentence for each piece or each part of the diagram. So the middle, that would be even numbers and multiples of 5. So it's what they have in common. This part, so let me just, that would be right there, okay? I'm going to erase that and do the next one. So this next piece, I'm looking at just this part, okay? That would be multiples of 5. And if you had different colors, you could color these in different colors on your notes. That would be helpful. So these would be multiples of 5 that are not even or odd. We'll just say odd multiples of 5, so they're not even. Okay, so I'm going to erase that. Whoops. Okay, and then over here, we've got even numbers that are not multiples of 5. Okay, and then we've got one last one, and that's the outside of the Venn diagram. So there's 4 different parts here: the middle, the 2 parts of the circle, and then the outside. So the outside are numbers that are not even or multiples of 5. So they don't fit in inside either circle or the overlap. Okay, so I would make it your goal, you know, if you didn't get any of these on your own, you know, this would be a good thing to just try later again on your own. See if you can identify what each part of the circle is. So let's move down and talk about, these are called attribute pieces, and there are a lot of different sets of attribute pieces on the market. Like if you just Google attribute pieces, you can see they sell all kinds of kits for elementary school students. I know the last time I worked in an elementary school, they had, you know, a box of these, and they were made of wood. They were just painted, and they looked exactly like this. So they didn't label them with the letters, but let me just show you what these letters represent. So for example, SYH stands for small yellow hexagon, LYH, large yellow hexagon. So we've got small and large, and then the middle letter represents the color. So for example, this is large blue circle, and the last letter represents the shape. So we've got yellow, blue, red, we've got small and large, and then we have hexagon, circle, and square. So a bunch of different attributes that we can look at, and there's all kinds of fun games for kids to play where they have to, you know, one game that I remember playing with kids is they'd have to make a train, and one kid would put a block on the carpet, and then the next kid would have to find a block that had one attribute similar to the first one. So maybe the first one was small yellow hexagon. They could put a, I don't know, large yellow triangle next because they're both yellow. So that's, you know, and they can make, you know, as big of a train as they can come up with. So these lend themselves really well to Venn diagram practice because we can talk about, you know, what blocks have in common and what they don't. Sometimes you'll have a Venn diagram that looks like this. So where you have two circles, but they're not overlapping. That's one way that you can draw a Venn diagram if there's nothing in common. So if there's nothing in common in the middle, you can just draw the circle separate if you'd like, and we call these sets disjoint. So for example, this circle is blue squares and yellow triangles. There are no attribute pieces that are both blue squares and yellow triangles, or they don't have anything in common, so we can just draw them separately. So example 2 asks, which of the following sets of attribute pieces are disjoint? So try to ask yourself, you know, which one of these questions, you know, are the two categories completely separate where they have nothing in common? So this would be a great place to pause the video and try this. All right, so I'm going to look at the first one. So large pieces and small pieces. And actually, I'm going to go back up so we can look at the pieces. So ask yourself, are there any pieces that are both large and small at the same time? And the answer is no. So those are going to be disjoint. If you were to draw a diagram, you would say, okay, this is going to be small and this is going to be large. They don't have anything in common. Okay, next, so number 2, small pieces and yellow pieces. So are there any pieces that are both small and yellow at the same time? There are. So we've got small yellow triangle, small yellow square, small yellow hexagon, and small yellow circle. So if we were to draw a diagram for that, so small and yellow, you would put all 4 of those items in the middle. So this is not disjoint because they have an attribute in common. So the next one, the last one, so small hexagons and blue triangles. So ask yourself, are there any attribute pieces that are both small hexagons and blue triangles at the same time? And there are not. So that one is also going to be, that's going to be disjoint. Okay, so again, disjoint is that they have nothing in common, and we draw the circles separately. Okay, so we're going to get back into the more abstract terminology here, and we're going to talk about subsets. I mean, it sounds abstract, some of it is, but it actually, I think, has a lot of application to real life, and I think kids, you know, as early as pre-K can understand like the basic nature of what it means for something to be a subset. They might not use the word, but they can understand the concept. So the definition of a subset is when you have a set, basically that's a part of another set. So, and the mathematical definition for that is just that, for instance, A is a subset of B. So this symbol right here stands for subset. I'm going to draw that again to make it look more like a sideways U. There we go. So we say A is a subset of B if every element in A is also in B. So the picture that would go with that, let me just scroll up here. You could draw a picture of circle B and then circle A. So everything that's inside of A is a part of B. So for example, you could say the set of dogs, so think of all the dogs out there, you could list all of those dogs, is a part of the group of mammals. Now, down here, we're going to talk about what a proper subset is. So this symbol is called a proper subset. A subset, it is possible for a subset to be a subset A to actually be the same size as set B. So it is possible to have a picture where here's A and then B is also on top of it. They're basically they're the same set. So for example, if I wrote it out like this, set A is the numbers 1, 2, 3, 4. Set B is a set of numbers 1, 2, 3, 4. We can say technically that set A is a subset of B, okay, because everything that's in A is also inside of B. So if an element is going to be a proper subset, it means there's got to be some other elements in B that are not in A, so the picture has to look like this, where A is a part of B, and there are some elements in B that are not in A. So almost visually just picture that A circle just being a little bit smaller, okay? So let's jump up and let's do a couple more examples here. So like if set A was the set of all the letters in the alphabet, we could say V is a set of vowels. V is a subset of A because all of the vowels are also part of the alphabet. And we can also say that V is a subset of A. V is also a proper subset of A because there are some letters in the alphabet that are not in that set of vowels. The set of vowels is not the same set as A, so we can also say it's a proper subset. So let's do some examples. So this would be a good place to, if you want to pause the video and try these on your own. So example 3, we've got the set N. It says list 3 subsets of N. So there are many different answers here. The set 1, that's inside of this set N. The set 2, 3, 5, that's inside of N. The set 4, 8, 9, 10, that's inside of N. I'm going to put ... There are many, many, many different examples. As long as you list a set that has elements that are inside of N, then it's considered a subset. Sets that are not a subset. So for example, the set with 15 is not a subset because 15 isn't in that list. The set with 20 and 21 is not in there. Or 100, 150, 200, 250. That set is not in N. There are infinitely many examples. Okay. Is the set 3, 4, 6 a proper subset of N? So let's draw a picture and then go back to the definition. So if we have set D, which is 3, 4, and 6, is that a part of, so are all elements in D inside of A? We would say yes, but in order to be a proper subset, let's back up. If we look at the definition, it means that there has to be some elements in A that are not in D. And is that the case? Well, yeah, because if we look at, oh, you know what? I put A there. Whoops, that should be N. Sorry about that. Okay, that should be N. So we've got 3, 4, and 6. Well, what are the other numbers that we're missing? So 1 should be in here, and then 2, 3, 4, missing 5, we're missing 7, 8, 9, 10. So I would say absolutely, D is a proper subset of N because there are some numbers that are in N that are not in D. Is set N a proper subset of itself? I would say no, it's not, because the set N, if we were to draw it like that, it is itself. So there aren't any additional items that are on the outside which would be necessary in order to call it a subset or a proper subset. So let me just erase that outside. There we go. Okay, so what else can we describe about sets? So we can describe the size. So some sets are finite, meaning they have a specific number of elements. They don't go on forever and ever. So 1, 2, 3, 4 is a finite set. The number of elements is called the cardinality. So for example, you could say the cardinality, I'll call this set W. The cardinality of set W is 4 because it has 4 elements. An infinite set is one that goes on forever, like the odd numbers. So I could write down 1, 3, 5, 7, 9, and anytime you see an ellipsis or the 3 dots, this just shows you that it's infinite. Okay. The other thing that we can do with sets is we can describe them as either equivalent or equal. Okay, so let's do an example of that, and then I'll talk about one-to-one correspondence. So equivalent sets have the same number of elements, okay, but they don't necessarily have to be the same. So, for example, sets 1, 2, 3, and 4, and the set with A, B, C, and D are considered equivalent. Okay, so that's one example. We can also say that set A, B, C is equivalent to itself, so it can be the same. These are equivalent, and then these two down here are equivalent. And the way that we test if two sets are equivalent is if they have one-to-one correspondence. And what that means, and this is a term you're going to see as early as, pre-K teachers all the way through elementary school, but we start in pre-K and we start looking for whether or not student or kids have a one-to-one correspondence, meaning can they take their finger and can they count items one by one, so match their finger with an item. So in terms of sets, a one-to-one correspondence just means that we can have a matching, so for every element in the one it can match up with the other, so that shows us that they're the same number of elements. Equal sets, on the other hand, have to be the same, so must be the exact same, have the same elements. So, for example, the set with x, y, and z, that's equal to the set x, y, and z. It's also equivalent, but it's equal. So one example, I cut and pasted a question. This is from IXL, which is an online math program, in their kindergarten section. And one of my children was working on this, and so I just kind of snapped a shot just because I thought it'd be helpful and relevant to this section. But are there enough marshmallows for every mug of hot chocolate? So they're basically being asked, like, okay, try to form a one-to-one correspondence and see if it works. Okay, in this case, there are not enough marshmallows for every mug of hot chocolate. So we would say no. Okay, so last but not least is the last page in the notes. We're going to talk about operations on sets. So this is definitely more of like a middle school, high school topic, but I think it's definitely relevant because it's, we're looking at Venn diagrams and we're looking at how they compare and contrast. And this is helpful because it helps us answer questions about Venn diagrams. So let's talk about, again, what the universal set is. So we have U here. If we look right here, we have U, which stands for the universal set. And those are all the numbers that we're going to include in this Venn diagram. So we have sets A and B, so I'm going to label the circles A and B. And I'm going to start to fill out this Venn diagram. And the first place I'm going to start is the very center. So I'm going to look at what these sets have in common. They have a 1, 3, and a 5. I'm going to put those numbers in the very center. After I'm done with that, I'm going to fill in the rest for A. So it looks like I'm missing 2 and 4. So now if you notice, I'm going to grab a different color here. If we look at just circle A has 1, 2, 3, 4, and 5, which is what it should have. Okay. And then I'm going to use blue here for circle B. So it already has 1, 3, 5 in the middle, but it looks like we need a 7 and a 9 there. Okay, and then we're missing some. So this is where the universal set is helpful because it tells us what we need to consider. So if we've got 1, 2, 3, 4, 5, 7, and 9, yet we're supposed to have numbers 1 through 10, then that tells us that 6, 8, and 10 need to go on the outside. So it helps us figure out what needs to go on the outside. So that's how we could draw that picture. Now let's talk about the operation. So the first operation is called the complement. So the complement of set A, you write it like this, is just all the elements not in A. So when I see this apostrophe, I just think of the word not. Anytime you see that apostrophe, just think of the word not, okay? So if we know, we're going to look at this a couple different ways. One way is to list out what's in set A. So if A is 1, 2, 3, 4, and 5, okay, we don't even have to look at the picture. Look at the universal set and ask yourself, what are the numbers that are in U that aren't in A? So if A is 1, 2, 3, 4, 5, then the complement of A is 6, 7, 8, 9, and 10. Okay. The other thing we can do is we can look at the picture. So if this is circle A and this is circle B, the complement of A would be everything that's outside of that circle A. And if we look up here, well, what's outside of this circle A? We've got 7, 9, 6, 8, and 10, and that's what we listed in our complement there. So feel free to do this visually, or if visually doesn't work for you, you don't have to do it visually at all. You can just list out the set. So either way is good. I think you just have to find what's right for you. Okay, so the next operation, we've got two more, union and intersection. So union is this letter. It looks like a U. It's technically a different key in the computer than a U, so it's slightly different font. But it looks like a U. So a union, okay, I want you to think of the word combine. And you can even think of marriage. So like when two people form a union or a marriage, they're combining, you know, their lives together. So if you have, I'll draw a picture and then I'll show you with the sets. So if this is the Venn diagram for circles A and B, the union of A and B would be all of A, all of what's in common, and all in B. So that would be the picture. In order to combine without using the picture, what I would do is I would identify, well, what is set A? You can write it out if you need to. What is set B? 1, 3, 5, 7, 9. And then the union, you're just going to put those together. So combine them together. So they both have 1. Now, if they have common elements, you only have to list it once. So they have a 1, there's a 2, they have a 3, a 4, a 5, a 7, and a 9. So even if one of them has it, but the other one doesn't, you're going to list it. You're just putting everything together. Okay. Intersection, on the other hand, it's a little bit more choosy. So intersection, which is the upside down U, I want you to think in common. So what do these sets have in common? And on the Venn diagram, that would be at the very middle where they overlap. If you wanted to write out the sets, which I think this is really helpful, this is a way that I like to do it. So write them out, put them right on top of each other, and then you can see what they haven't. Whoops, that didn't turn out very well, did it? All right, let me get my blue pen back. Okay, so they have a 1 in common, they've got a 3, they've got a 5. So we would list A intersect B to be 1, 3, and 5. Okay, so that would be the answer if you were asked to find A intersect B. So let's do a couple of examples, and I think these are going to be really helpful. So we've got 4 examples. We start from an easy example and then down to the hardest type of example, which is in box D. And I think if you can do all of these, you know, at a certain point, then that's a really good sign that you understand what's going on. So let's do the first one. So remember that this apostrophe, this means, think of this as not, okay? It stands for, it's called the complement of C, but just think of the word not. So this means the set of everything not in C. So if the set C has 2, 3, 5, and 7, then what you need to do is you need to look at set U, the universal set, and you need to ask yourself, well, what is not in C? So if C is 2, 3, 5, and 7, then the other numbers, 1, 4, 6, and 8, are going to be in the complement. Okay, so for the next one, A intersect B complement, you want to use the order of operations for these. So there's a couple different pieces here, just like the order of operations. If you were doing just like an algebra problem, you always want to start in the inside of the parentheses. So we're going to start on the inside first. I'm just going to put a little 1 there, standing for first. And then we're going to do the complement next. So that's going to be second. So we're first going to take A and B, and I'm going to list those out. And some people do not have to write this all down, but I do think it's helpful because it's really easy to make silly mistakes in these problems. And then ask yourself, what do these sets have in common? Well, they have nothing in common. So A intersect B, we're going to say is the empty set. They have nothing in common. So the next part, okay, I'm going to come up here, is we're going to say, okay, well, what's the complement of the empty set? And remember, the complement, we think of the word not. So what's not in the empty set, okay, but in you? Well, that would be everything. 1, 2, 3, 4, 5, 6, 7, 8 are all not in the empty set. So the answer, you could write out the whole set like this, or even easier, just say you, okay, because it stands for the same thing. Kind of a weird problem, but I'm glad we did one like that in case it comes up for you in the homework. Okay, so the next one, notice there's no parentheses. So we're going to look at the complements first. It doesn't matter what order you do those in. So I'll say we'll do A complement first, and then we'll do C complement. And then last, we're going to intersect them, meaning we're going to find what they have in common. And you know what? It might even be helpful when you're doing these problems to actually write in common to remind yourself what you're needing to do. So A complement, so let's go up here and let's look at A. If A is 1, 3, 5, and 7, then A complement is what's not in that set. So what's not in 1, 3, 5, 7? Well, the other remaining numbers. So 2, 4, 6, and 8. Okay, what's not in C? So we did that above. Okay, so we said C complement is 1, 4, 6, and 8. And then the intersection is just what's in common with those two lists. So it looks like they have 4, 6, 8 in common. So 4, 6, and 8 is going to go in that final set, and that's going to be your answer. Okay. So last but not least, this one's a little bit longer. So you got lots of parts. Just like in part B, there's parentheses. So you're going to want to do those parentheses first. So I'm going to say I put a little number 1 here. So you're going to do the parentheses first. Then we're going to do C complement, and then we're going to do the intersection or find out what those two have in common. So for step 1 here, we're going to do A union B. Remember, union means to combine. It means to put those sets together into one big set. So if we look at A and B, looks like they have together collectively a 1, a 2, a 3, a 4, a 5, a 6, 7, and an 8. You don't have to put them in order. You could have listed A, 1, 3, 5, 7, and then 2, 4, 6, 8 next if that's easier. I like putting the numbers in order because then it makes it easier on this next step, but you could do it either way. So step 2, we're going to list out C complement, and we already did that in part A. So we said that was 1, 4, 6, and 8. And then last, we're going to put it all together. So we're going to say A union B, which is what I did in that first part, intersect with C complement. So we're going to look at these sets and we're going to identify, okay, they've got a 1 in common, they've got a 4 in common, they've got a 6 in common, and they've got an 8 in common. So your answer is going to be 1, 4, 6, and 8. Okay. So I hope that helped. I think these problems are really important for you to go through and do on your own. So if you were watching this video and just kind of working along with me, I highly advise that you go through and try a couple of these. Maybe later when you've forgotten a little bit, try them on your own and see if you can get through to the end. So, and as always, let me know if you have questions.